All right, folks, I'd like you to set up your notes just like this. So maybe put the video on pause so you can get everything set up. All right, thanks for doing that. Hey, let's remember something. Let's go to Desmos. I've got that file attached below in Google Classroom. And if you have a number that's going to be subtracted from x, so inside the function, we have like x minus 3, x minus 5. Okay, so what's this going to look like in our homework? It's going to look like this, like 2x minus pi. Now, I'm going to point out that the 2 is in a really bad spot for seeing this one like super obvious. So we're going to modify the way that this looks here in just a second. But you can see there's a little subtraction going on inside the sine function, right? So what happens, if you had an x minus 2, let's say, to our basic sine function? Well, let's turn on this guy down here. It's been modified. And here's the part that makes it challenging. This is a periodic function. It goes like, here's an x-intercept, here's an x-intercept, right? There's infinitely many x-intercepts. So when we're looking for the x-intercept that matches our, really important starting point, somebody could look all the way back here and see, hey, right here, that's maybe where the starting point moved. This point got moved way the heck over here. Or maybe this point got moved over here. Or maybe this point got moved over here. Do you see how there's infinitely many places where the point theoretically could have been moved to, and you wouldn't be able to tell the red function got moved onto the blue function in some way, right? Well, you might be looking over here going, well, look, Nelson, I can see it's 2 right there. So we want the one that went 2 to the right. So this is our key point right over here, okay? So let me turn on a point that matches that point. I've already made one here for you. And so let's watch what happens here as I move this point right here. This 2 becomes 3. So what's really going on here is we're doing, let me change this guy right over here to just basic, like sine, right? That's what my f function was. I'm putting x minus h into the sine function, and the h is 3. So it's really just like, I could change this to a 3 so it makes it more obvious too. But now when I move the slider, this isn't going to move left and right. Okay, so if I change this back to h, you can see if I move the slider over to 5, right? So here the slider's 5, it's been moved 5 to the right. So if you saw a sine of x minus 5, you would know that this starting point is going to move 5 to the right. Now, like I was saying, this problem right here is a little bit more complicated because there's a 2 right there. Okay, so let's see what happens if I put a 2 right in front of the x. You notice my corresponding point down here, it's like, what the heck, man? That's a minimum value. That's not a starting location for the sine function. That's a minimum value. So it's really tough to see what happened here. So what I want to do is I want to factor the 2 out of this set of parentheses. So if I put a parenthesis like right here, and then this would have to now be h divided by 2 in order to distribute this through and end up right back to where we were before. You can see that point didn't move anywhere, right? So if we could factor a 2 out of some expression here, now we can see that the 5 would be like right here. Now it's super obvious. See, our starting point's been moved 5 to the right. So what we want it to look like is more like this, like 2 times the quantity. So let's compare that to our problem from the homework. See, this one has 2 times x minus pi. So we've got to factor the 2 out like I was kind of putting down a second ago. Hopefully that didn't confuse anybody, that factor there. But I'm going to go 6 times sine of 2 to the, now let's see, what would it have to be, what would I have to have inside these parentheses? Well, I'd have to have an x right there so that when I distribute the 2 through, I would end up with 2x. And then over here, I'd have to have pi over 2 so that when I distribute the 2 over to here, it ends up right. I mean, I can't generate a different function. I have to have the same function just looking different down below. It's got to be the same exact function just looking different. So now, because it looks different, I can easily see, here it is right here. Here's my phase shift. This means our sine function is getting moved pi halves to the right, right? So let's look back over here. Do you notice a little minus sign right here? So if we had minus 5, it moves 5 to the right. If I had in here, let's move this to like a negative for a second, like a minus 3 here. So if there was a minus 3 sitting there, it'd be x plus 3. So if you saw x plus 3, the starting point has been moved 3 to the left, okay? So because I see a minus pi halves, what I'm going to do is I'm going to move my, like normally the sine function starts there, I'm going to move it over here a little ways. Okay, so I'm going to move it to the right by pi halves. Now, I don't want to crunch everything in a tiny little space. I don't want an entire sine function to happen right in here. So I'm not going to put my tick mark down here, because as soon as I say this distance is pi halves, you know, let's say the next distance I need to mark off is 5 pi. Well, 5 pi is going to be like way the heck over here. So I might want to make like pi halves super close in here, right? So what I want to do next is I want to figure out the period. So the period is 2 pi divided by b. So I go 2 pi divided by that 2 right there, right? This is my b value right there. So I'm taking 2 pi divided by b, which is 2 pi divided by 2, which comes out to be pi. Okay, so this is a good example of like, if I go over and I call this pi halves, well, then we'd go like pi, and then we'd go to 3 pi halves, and this distance right here is going to represent an entire period of our function. So I'd like pi halves to be a little bit longer. Like I'm going to say this is pi halves. So watch what happens next. So if that's my scale, and then I go over here and I say, okay, here's, let's say I'm trying to make something that's equal to that right there, then this would be 1 full pi. Then if I go another pi halves, this is going to be 3 pi halves over here, 3 pi over 2. So this distance from here over to here is now 1 full period, right? Let me undo where I put that little red mark here. Let's put it down below. So from here over to here, that's 1 full period. So I'm trying to spread out the period as much as I can so that my little sine function doesn't get completely crunched in between these two guys. And that's why I had to do a little bit of thinking, like if I'm going to make this pi halves, that would kind of spread things out enough, right? The rest of this is pretty easy. I put a 6 up at the top. I put a negative 6 down below. Why is that happening? Because here's our amplitude right here, right? And there's no vertical shift on the function. So this is y equals 0 right over here, right? Okay, next thing I'm going to do is I'm going to put a dot right here. So my starting point would have been right over here, but it got moved over there. It got shifted. This is called the phase shift. Phase shift, okay? Sometimes they use a Greek letter for that. They might use phi, like this. This is phi here. Oh, shoot, that's a bad phi. This is phi, like that. It looks like a 0 with a line kind of going through it. Sometimes they'll use gamma. Sometimes they'll use theta. So you just have to be careful. Like they're going to use a Greek letter probably for that value over here. I like using h. Okay, what's the next thing we do? Well, the sine function has got to complete a full cycle over to 3 pi halves, so might as well put that guy there. And then we break it into 4 parts, right? This is the distance that we're breaking into 4 parts. Well, it's already broken in half, so all we need to do is put tick marks in between here. Oh, geez, let's see. This is a pi half between here, so this must be a pi fourth, right, to there. So this would be 3 pi fourths right here. And then we've got 4 pi fourths, then we got 5 pi fourths. Okay, so how did I do that? I said this distance right here is pi halves. So if we take pi halves and we divide it by 2, you just double the denominator to cut a fraction in half, right? So that's pi fourths. So this was 2 pi fourths. This is 3 pi fourths. This, right? Let me write that down maybe. 2 pi fourths. Then we added a pi fourth, and we add another pi fourth, another pi fourth, another pi fourth. It all works out, right? So we go up to our maximum because this is a sine function, so it goes from neutral to max to neutral to minimum, back to neutral, and then we're just going to try to connect those as smoothly as we can, try not to miss any of them. And that's how we shift a function left to right. Now, I'm going to ask you just to show one full period because it's super obvious that you have located the starting point when you show me one full period. If you put 2 periods down, it's going to be hard for me to kind of see, oh yeah, they definitely know which way this thing got shifted. All right? So I want you to try some homework problems, and then we're going to try some together. I know you can do this. I hope I made it clear. Thanks for watching my video.